Cloud Gurus, and welcome to this lecture. In this lecture, we'll take a look at the structure and design of the Google Cloud Platform. First, let's take a look at some of the design principles. GCP has really been designed to be a global offering. Security is also built into every level of the system, and the whole thing scales like mad. Also, as you will remember from our previous lecture, it's very much designed with developers in mind. So let's start by taking a look at the global perspective. GCP is intrinsically global. What I mean by this is that the services are generally built to serve worldwide customers. In this case, I'm not talking about how well it scales to meet the demand of lots of people around the world. I'm more talking about giving a good user experience to each of the people in their different locations around the world. Even with the fastest fiber optic networking, it can still take a noticeable amount of time for data to get around the world. So this really does matter. Now, by comparison, I would say that Amazon Web Services is intrinsically region-scoped. So one of the benefits of the regional model is that it simplifies data sovereignty. You know exactly where your data is physically because it never moves unless you make it move. That said, the global model is optimizing for a different thing. It makes it much easier to handle latency and failures in a global way, things that would wind up being very difficult to do in the regional model. Now, the global model could be more sensitive to failures that affect multiple regions or the entire system all at once, but that doesn't mean that the regional model is immune either. I remember hearing that when Amazon's S3 service was broken in North Virginia, people in Sydney, Australia unexpectedly couldn't use the console. I'll point out that these failures would wind up being service failures, not failures due to the underlying hardware. So let's take a look at the physical infrastructure underlying the Google Cloud Platform. At the very bottom level, closest to the hardware, there's going to be some program that runs on a central processing unit. Those CPUs exist on some physical server, in some rack, in some data center. The data center here is an actual building full of a whole bunch of computing capability, and how Google manages this is serious business. One important thing to understand is that they have clear separation of duties. The people who work in the data centers have no access to the services, and the people who work on the services have no access to the data centers. There are a couple of really interesting YouTube videos that you can check out where they give you a virtual tour of the data center. One of them is a more normal video, and the other is a 360-degree tour where you can look all around yourself if you're using Google Cardboard. In any case, one or more data centers together are logically grouped together into what's called a zone. The key thing to know about zones is that each zone is designed to be as independent as possible from all other zones. Independent backup generators, maybe even connecting to different electrical grids, independent network connections to the rest of the Google network. If some data center in a zone burns down, that should have no impact whatsoever on anything running in a different zone. So zones are made to be independent of each other, but they're still grouped together in what's called a region. The zones within one region can communicate really quickly with each other. Maybe not as quickly as you could communicate within a zone or a single data center, but definitely very quickly still. Now, different regions are grouped together in what are called multi-regions. Each of the regions in a multi-region is at least 100 miles away from the others to help address certain kinds of concerns around physical proximity. Now, remember how I said that GCP was designed as a global system? Well, this is where it really starts to show. All of these regions and zones are connected by a private global network. Google has strung fiber all around the world to connect up its data centers. So traffic from one server to another never even has to touch the internet. Of course, some stuff does have to interact with the internet, and that's where the different points of presence come in. These are the edges of Google's private network that connect to the internet, and a lot of content distribution network locations. Altogether, this makes up a global system. So let's take a look at how this looks around the world. This is a map where each pushpin represents a region in the world, and the number on the pushpin tells you how many zones are in that particular region. There are regions like US Central 1, which is in Council Bluffs, Iowa, Europe West 3, which is in Frankfurt, Germany, and Australia Southeast 1, which is in Sydney. The multi-regions are Europe, Asia, and the US, or North America. Australia and South America can't yet be multi-regions because they currently only have one region each. This map shows Google's private global network, and each of the dots represents a place where data can either enter or exit that network. Usually those interchanges are with the public internet, but it's also possible to have private interconnections with Google's network. So let's take a closer look at what this network means. Normally, you'd expect data to travel on the public internet to the place that's closest to the destination. Then it would connect into the private network of that particular data center. But with Google's network, data can actually travel to the connection point closest to the source. And this enables some very interesting scenarios. For example, you could have a single global IP address that could load balance across all of your servers worldwide. When someone goes to that IP address, they would generally hit the server that's closest to them physically, so they'd get really fast responses. But if that close server or region is overloaded, it can just load balance some of the traffic to another region at a slightly higher latency. And because you can work with global IP addresses, this can sidestep a lot of issues with DNS. Now, GCP used to have just one mode, where data would spend as much time as possible inside the private network. But it's now possible to opt for a normal network routing policy to reduce the price somewhat, of course also reducing the functionality. And this is a good time to talk a bit about how pricing works. One of the ways you might pay for a service is by provisioning a certain capability. You tell Google, make sure you're ready to handle this amount of load. Have those resources sitting there and waiting for my stuff. In this model, you're paying for the resources to be ready for you, regardless of whether you wind up using them. The other model is by usage, where you say to the service, handle whatever I use, and charge me for that. Now, unfortunately, this isn't something that you generally get to choose one or the other. It's that the service is built to either be provisioned or to charge based on usage. Another thing you have to pay for is network traffic. Network traffic is always free on the way in, but it's on the way out it gets a little more complicated. In general, you're charged on the way out by how many gigabytes of traffic you send. But when you're communicating with other Google Cloud Platform services, this is sometimes free, depending on the specific service and where it's located. In general, you don't pay to send data to other Google Cloud Platform services in the same region unless those services live in a particular zone. Security is a really important design principle for the Google Cloud Platform. If you watch those YouTube videos I linked, you'll see very clearly that there's a separation of duties and a lot of attention paid to the physical security of the data centers housing the GCP services. Beyond that, though, absolutely everything in GCP is always encrypted at rest. You don't have to turn on encryption yourself, though you certainly can and take advantage of the strong key management services they have. Key management and other access is all tied into the identity management, which is a core part of GCP. Network encryption is another thing to think about. All control information with GCP services is always encrypted, and all wide area network traffic between regions will soon be encrypted automatically. They're also moving towards encrypting all the local traffic within the data centers. But even with all of the network security stuff, the general model is to distrust the network. This is following the security best practice of defense in depth, having layers of security. And Google's developed a whole security model called BeyondCorp that shifts access controls from the network perimeter to individual devices and users. This can allow employees to work securely from any location without needing a VPN. You can read more about how Google has designed security into the Google Cloud Platform at this link here. Continuing on, from Google's perspective, you can't have a service that can only handle 1 billion web pages and then falls over. It has to be able to handle like trillions or more, in theory. Everything has to be able to scale, basically infinitely. And despite that scaling, nobody wants to be answering pages of things that have gone wrong, and especially not developers. So if it can be automated, it should be. And it can be automated. It can all be automated. That's basically one of the principles behind site reliability engineering. You engineer the reliability into the systems. You automate the things to respond appropriately. But there are still some guardrails in place to protect you from some mistakes and to help Google better manage their load spikes. Basically, a quota is how much of a particular service you're allowed to use, and some of these might be regional and others might be global. If you wind up hitting the limit for a valid business reason, you can get this changed. Sometimes Google might actually change these automatically for you, but otherwise you can also request that they be changed, and they'll respond to those requests in 24 to 48 hours, but they might say no, depending on what you're asking for. Also, it may be useful to know that you can query for your current limits, running this gcloud command. We'll get into gcloud more later on, but in particular, this asks Google to tell you what your current limits are for this particular project. And that brings us to the next topic, which is projects. Projects are the primary unit of organization in Google Cloud Platform. Just for reference, a project is kind of similar to what an AWS account is. In particular, every resource is owned by a single project, though it is still possible to share these resources across other projects, but it's still one project that owns and gets billed for it. But your GCP account can have multiple projects in it, and you can group and control these in a hierarchy. Alright, this has been a really quick and high-level look at the Google Cloud Platform, but I hope you found it useful to understand a bit better how GCP is built. If you have any questions for me, please let me know. If not, please feel free to move on to the next lecture. Thank you.